In this video, I'll be helping you with a math topic called subtracting square roots. And this example is taken from the OpenStax college algebra text. We can see that we're asked to subtract these two expressions here. However, the radicals are not the same. And in order to add or subtract combining these two expressions, the radical portions must be exactly the same. They're not, but they both look as though they could be simplified. So I'll start by trying to simplify these. The first expression has 20 on the outside of the radical. And then looking at the 72, the numerical portion, can I write 72 as the product of a perfect square? And here, yes, 72 is 36, a perfect square, times 2. And then for a to the third, can I write it as a product of a perfect square? And since we have powers here, I would want one of those powers to be a multiple of 2 because it's a square root. And similarly, I can write this as a2, which is a multiple of 2, times a single a, or a1. And then b to the fourth is already a perfect square. That power is a multiple of 2. So I'll just write that b4. And then there's nothing that I can do with the c, so I'll just bring that down. And doing the same for that second expression, I have a 14 on the outside of the radical. The numerical part, 8, can be written as the product with a perfect square. 8 is 4. A perfect square times 2, it has an a3, which I can again write as a2 times a, since the 2 is a multiple of our 2 that is the square root. The b4 is already a perfect square. We'll simplify that in the next step. And like the first one, we have the single c. From here, we can start to simplify each of these. For the first, I'm going to give some space here. I already have the 20 outside the radical, but this 36 can come out. The square root of 36 is 6, so this 20 is going to be joined by a 6. The 2 is not a perfect square. It'll have to stay in the radical. The a2 can come out as just an a, and recall here that we're dividing by the power of the root here, 2. 2 divided by 2 is just the 1, so it's a single a. The other a is left under the radical. The b4 can come out of the radical. 4 divided by 2 is 2, so that's a b2, leaving me with the c under the radical. And then for this second expression, doing the same, the 4 comes outside as a 2, leaving me this 2 still under the radical. And then like in the first example, the a squared comes out as an a. 2 divided by 2 is 1, so just to the first power. This other a is still under the radical. The b4 comes out as a b4 divided by 2, which is 2. And then the remaining c. So we have a left side and a right side here that we can continue to simplify. 20 times 6 is 120. We have an a and a b squared outside the radical, and a 2ac under the radical, minus 14 times 2 is 28. Again, I have an a and a b squared outside the radical, and a 2ac inside the radical. And in order to combine these two expressions, I have to have the same variables to the same power, including the radicals. And that is exactly what we have here. We have a b squared square root of 2ac, a b squared square root of 2ac. So looking at these coefficients, 120 minus 28 gives us a 92. A b squared square root of 2ac. And this is our simplest way of writing this expression. A less simplified answer could have been gotten to by just trying to get the radicals to be the same. But since we simplified the radicals as much as possible, not only were we able to subtract, but we were able to write the answer in its simplest form.